Hello everybody, and welcome to, a really quick video on solving some equations through factoring. Kind of like this good little wrap up, and hopefully it's something you've pretty much already done. So real quick, right, one of the biggest reasons that you factor is to use the zero product property in order to solve equations, right? So let's say you've already factored something and you've set it equal to 0. Now, that 0 is so important because once you've already factored everything, you should be able to sort of see the solutions almost immediately, right? Now, I ask myself, what makes this equation, well, equal to 0? All these things are multiplication, including that x there. So, well, when x is 0, I get 0 times negative 4. It doesn't matter what the rest is. It's going to be 0, right? When x is 4, that's going to make this factor 0, right? When x is negative 1/2, it's going to make that 0. If you have to really quick, hopefully this is something in your head, but if you have to solve that and ask yourself what x value would make it equal to 0, you can make that little equation, and then x equals negative 3 makes it true. So now if we expressed the solution set, let's do it from least to greatest. So negative 3, negative 1/2, 0, and 4, right? And that set notation is not an interval, but there are 4 values that make this statement true, right? These values make the statement true. Okay? So there's only really a couple things you need to make sure you do before you solve, right? Make sure that you set one side of the equation equal to 0. You absolutely have to do this. This zero product property only works with 0, right? Doesn't make much sense to do with any other number, right? Because it's so easy to see. All you need is one factor to be 0 for everything else for the entire side of that equation to be 0, right? You also want to make sure you write the polynomial in standard form. This is why we keep stressing that standard form, right, before you factor, right? Sometimes it won't reveal itself until it's in standard form. So we'll just try a few, and I think you guys will be fine, all right? So number 1, I see it's not equal to 0. Let's subtract that 3, right? My lead coefficient is just 1, so we can use sort of the shortcut here, and we should be able to see it really quickly. It factors to this. Now, the most important thing I see people getting wrong, if it says to solve, right, then we keep going through. If it just said factor, right, in factored form, you don't go past this, right? These are the factors. When you solve, when it's an equation, that's when you write, x such that x equals negative 9 and 5, right? We say, okay, what values make this equal to 0? What make that equal to 0? Okay, so make sure you're following the instructions, whether it's solving it or just factoring it. If there is no equation, you do not do this step, right? If it's not asking for solutions, you do not do that step, okay? All right. Good news here, this is already set equal to 0, but something really important is happening here, right? We have a GCF. GCF is x, right? That's a really important step, right? That x is a factor, right? It's the greatest common factor, and it's also a factor that can be 0, right? If you want to put parentheses around it, you can. You don't have to. The rest will factor to x plus 10, x plus 2, right? This will make 3 solutions, though, right? X equals 0, negative 10, negative 2. We'll write it as negative 10, negative 2, and 0. Notice how, in number 1, 0 is not a solution, right? Plugging in 0 to x does not make this statement true. Right, I get negative 42 equals 3 back into the original. Plugging in 0 here, though, it is true. You get 0 plus 0 plus 0 equals 0. So when you have that factor of x, it's going to lead to 0. Okay? And we'll look at a couple more coming up. All right? Why don't you go ahead and try 3 and 4, right? You can pause this now. Try 3 and 4. All right, let's see how you did. So negative 5x squared plus 11x, and you add the 6 over, you should get negative 6 equals 0, right? Now it's in standard form. It's equal to 0. I do want to factor out that negative. In this case, if you didn't, it's okay. You don't need to. But now you actually have the option, if you would like to divide by negative 1, you can, right? Dividing by a constant is an acceptable move when the one side is equal to 0. Doesn't affect us at all, right? You could also just leave that negative out there. That can never be 0, so it really doesn't have an impact on the rest of the problem, right? So now we're going to factor, and by now, right, you just have to have your one method down, right? Whether it is AC, whether it is just guess and check, but either way you do it, you should have gotten that. All right. Now, this will be 6/5. This will be 1, right? Just make sure you get the fraction right. You're going to add 6 and divide by 5 to get that 6/5, right? And then we express it in set notation, x equals 1 and 6/5. Okay? All right, a couple more. Hopefully this one you saw it was going to be 3x plus 8x plus 4 when you subtract 3 and add 8x to each side equal to 0. 3x and x, the only things that can go there. And I also just get a plus 2 and a plus 2, right, to make my 8x. Again, any way you do that is fine with me. X equals negative 2/3, x equals negative 2. Make that equation true, right? So you're left with x equals negative 2 and negative 2/3. And notice how I put it from least to greatest. You're listing out all the solutions, okay? All right, a couple more. This one's interesting. I'm going to still set one side equal to 0. Now, you could have solved this pretty straightforward, right? You could divide each side by 2 to begin with and take the square root. If it says to do it by factoring, you must do it with factoring, okay? Please do it with factoring. In this step, though, if you want to divide out by a constant, you can. Again, if you didn't, you would be left with this 2, right? It doesn't really come into play, though, right? So that 2 can never be 0. It's not related to the solutions. It divides out in either way, right? So it's kind of up to you where you do that, okay? And you get x equals negative 3 and 3. And we'll just put that in set notation, okay? Now, this one, it's a good thing to ask yourself, what can I divide out and what can't I? You can divide a 3, right? If you wanted to. You cannot divide by x squared, right? The reason is you potentially lose a solution and you could potentially be dividing by 0 if x squared was equal to 0. So what I would suggest is still do your GCF, right? The GCF here is 3x squared, right? Now 3x squared is the greatest common factor. I can ask myself, can this be 0? Absolutely, right? Well, when x is 0, right? The only other solution is when x is 4. Later on, when we solve polynomial equations, we'll talk about multiplicity, but for now, there are two values, that make this equation true. And the values are 0 and 4, right? Plug them in. 0, if you plugged in 0 here, 3 times 0 cubed minus 12 times 0 squared, that's 0. 4 is going to work as well. Okay? I'm going to do one of these, I'll do 7 and 9 with you, and then 8 and 10 you guys are going to try out on your own. Create equation in standard form that has the solutions. This is just working backwards, right? Now notice it says create an equation, right? So I ask myself, if these are the answers, they must have come from these factors which were equal to 0. So the equation that I'd be making is x squared, FOIL it out, minus x minus 12 equals 0. Okay? Now, if I still want to create a quadratic equation that has the following solution, well, this is interesting. I could say, oh, 7, well, that would just be x minus 7. But that's not a quadratic. That's a line, right? I can't really add another factor, right? Because then I'd be introducing another solution. I can't say x plus 3, right? Because then there's 2 solutions. It's only listing 1. So my only option is to say, you know what? It's just this factor twice, right? It's really just x minus 7 times x minus 7. I just get that solution twice, right? The same answer twice, right? If I do want to put it in standard form, right, I would just multiply this out. And by now we should recognize that immediately as a perfect square trinomial, right? This equation only has one solution because it would factor to that, right? The only solution is 7, okay? Go ahead, you can pause this. I will show you the answers, but pause, try the rest, and hopefully you'll be good. Okay, one little trick for this, you could write x minus 1/2 and x plus 5, right? Generally, we don't want this, we don't want these to have decimals or fractions. So one little trick is you can introduce a GCF that's just a constant, right? So really the way that would come in is multiply by 2, right? If you do that, you are not changing the solutions, right? Notice how this 2x minus 1 would still have 1/2 as a solution. So multiplying by any constant keeps this statement, keeps these solutions intact, right? And then it's just a FOIL, 2x squared minus x plus 10x, so that's plus 9x minus 5 equals 0. Okay. Last but not least, this has 3 solutions, and you should have put a factor of x in the beginning, right? Now you might have started with this, but what I would say is multiply this one by 3, right? Multiply by the denominator so that you create an equation with no fractions, right? So you're left with x minus 5, and 3x plus 1, right? FOIL it out. Let's multiply this first. X squared minus 5x times 3x plus 1. And we're left with what? 3x cubed minus 15x squared plus 1x squared is minus 14x squared minus 5x. Oops. Equals 0. Okay. So hopefully this wasn't too bad. Really, it's one of the biggest reasons that factoring is so important and we get it down so efficiently and effectively. All right, let me know if you have any questions, guys, and I will see you soon. Bye, buddies.